Hi guys, we're on chapter 18. We're going to cover section A today, and there's a lot to cover, so buckle up. All right, so let's talk about the atmosphere. Basically, it's all the gases that surround the Earth. It's a very thin layer, relatively, of gases surrounding the Earth, okay? And it's kind of important to understand that the gas spreads out gradually as you get to the edge of the atmosphere, okay? So down at sea level is the densest it gets, and it's not like there's a wall, okay? So it's not like there's this rigid layer where all of a sudden it's like, you've got space, and that says space, believe it or not, then you're in the atmosphere. It's a gradual decrease, and it just kind of happens, okay? The atmosphere, by definition, is considered about 300 miles thick, but the majority of the gases are within 10 miles of the surface, okay? Because that's where it's the most dense, and then they spread out and spread out and spread out, okay? Weather is a description of the conditions of the atmosphere, wherever you are, okay? So if you look outside, right now it's sunny, it's a little chilly, so the atmosphere, the condition of the atmosphere where I am right now would be the weather. Okay. We'll talk about climate later, and that's kind of like patterns and stuff. But weather is the actual condition in the atmosphere where you are. So why is the sky blue? We're going to watch a video on this. It's kind of complicated, but I'll try to give you a simple answer, and the video might help as well. So basically, when light enters the atmosphere, okay, light comes from the sun as electromagnetic waves, okay? When it hits the atmosphere, it starts bouncing around in those gas particles, okay? And so the light gets scattered a little bit. Blue gets scattered the most, okay? So the light that comes from the sun, it actually has different visible spectrum, and that's the colors of the rainbow: red, orange, yellow, green, blue, purple, okay? So the light rays that make up the blue light get bounced around the most, and so that's what we see as a result of that, okay? Except at sunrise and sunset. So if you're here, okay, and the sun's out here, and it's either coming up or going down, the light rays have a much greater distance of atmosphere to travel through to get to you. In the middle of the day, it's a shorter distance, okay? Sunrise and sunset, that additional scattering basically leaves the red light behind, okay? Everything else is kind of scattered away, and so then you see the red light the most. And so that's why sunrise and sunset starts to take on those pink and orange and reddish tones because of that, okay? All right, so we've talked about the composition of the atmosphere, of the air around us before, but really that's just down at the surface, okay? So the atmosphere is separated between the homosphere, which is close to the surface, and then the heterosphere, which is the rest of it. The homosphere is a pretty equally mixed layer of gases, and it's got this composition right here. So about 78% nitrogen, 21% oxygen, and 1% other gases like carbon dioxide and helium and argon and funky things like that, okay? When you get above that, and actually you can see this on page 432, you get into what's known as the heterosphere. This is above 80 kilometers from the surface, okay? And the gases start to kind of separate into distinct layers. You get like an oxygen layer and a nitrogen layer. The heavier gases are towards the bottom. The lighter, less dense gases like hydrogen and helium form layers right up at the top of the atmosphere, okay? So that's homosphere and heterosphere. We also have multiple layers of atmosphere named based on their temperatures, okay, and kind of what happens there. If you look on page 435, you can see a picture of that. I've got a diagram here. I'm not going to have you guys remember the temperatures, but I do want you to know the names, okay? So the lowest level, the one that we're closest to when we're in, is the troposphere, okay? This is where weather happens. Most of the clouds we see are within the troposphere, okay? Above that, we go to the stratosphere. The ozone layer is there, which we're going to talk about in the next section. The ozone layer absorbs harmful UV light from the sun, so it's really important. We'll talk about it more. And jets like that go up pretty high, like 36,000 feet, 38,000 feet. They're actually kind of in the lower part of the stratosphere. not so much commercial jets, but like military jets can fly up that high for sure. Okay. Above that, we get the mesosphere. So if you ever see a shooting star, what's happened is a meteor has entered the mesosphere, and there's more. So as you're moving down these layers, the density of the air increases, okay, meaning there are more air particles, okay? So out here, the air particles are fairly spread out. There's not as much friction. When it gets to the mesosphere, there's enough air that there's a lot of friction with these meteors hitting it, okay? And so what you're seeing is these meteors burning up because of all that friction, and that takes place in the mesosphere. Above that is the thermosphere. This is considered the top layer of the atmosphere, and it just gradually blends in with space. Eventually, the air is so spread out, you're considered to be in space, okay? We also talk about the exosphere, and that's kind of the gap between space and the thermosphere, okay? So it's like the last part of the thermosphere is called the exosphere, and then basically you're in space, okay? We've talked about the water cycle before. But within the atmosphere, we also have these things called the carbon cycle and the nitrogen cycle. And we talked about these very briefly when we were talking about the ocean. We're going to talk about them a little bit more, but still nothing super extensive. The carbon cycle is on page 437, okay? So carbon is a really, really important element for life. Our bodies are made up of carbon. We need carbon. And so like water, there needs to be a supply of carbon, okay? There's a lot of carbon in the atmosphere as carbon dioxide, but where does it come from? Where does it go? Because we don't want too much of it either, okay? So the carbon cycle is basically a flow of carbon between living things and the environment and back again. And we've got these different reservoirs, okay? This word right here, and these are just kind of like storage areas for carbon. And the atmosphere is like a reservoir for carbon, as carbon dioxide, okay? So plants need carbon dioxide. They use it for photosynthesis. We produce carbon dioxide, okay? We breathe in oxygen. Our bodies do this chemical reaction that you'll learn about next year, and we exhale carbon dioxide. So there's a nice balance between plants and animals that way, okay? When things die and decay, the carbon is kind of released from their bodies, and that sinks back out down into the ground, into the soil reserves, and that's where fossil fuels come from. When we burn fossil fuels in factories, it releases carbon dioxide to the air, okay? Carbon dioxide, I forgot an N there, carbon dioxide can also dissolve into groundwater and into the ocean. So there are also carbon reserves in the ocean as well, okay? Carbon dioxide is necessary for plants, but it's considered a greenhouse gas, which we'll talk about later on, and adds to the increasing temperatures. And so we do have to be careful with how much we're dumping from this into the environment. If we keep the cycle pretty stable, though, we're doing all right. There's also the nitrogen cycle, okay? The largest reservoir of nitrogen is in the atmosphere, okay? We just talked about how the lower part of the atmosphere is 78% nitrogen. But that's in a form that really isn't usable to living things, okay? So it needs to be fixed. We talked about this a little bit with oceans. There are nitrogen-fixing bacteria in the soil and in the oceans that change that N2, which is the version that's in the atmosphere, into ammonia, okay, which is NH3. It breaks the N2 apart and adds some hydrogen, and it basically just makes it a usable form, okay? Once it's fixed, it's considered usable, okay? Lightning can also do some nitrogen fixing in the atmosphere. When lightning strikes, it could actually break apart some of that nitrogen and make it more usable as well. That's it. Section A.